The Mantidfly holds three borrowed identities at once: a praying mantis's spiked, grasping front legs, a lacewing's veined wings, and a wasp's black and yellow warning stripes, all fused onto one insect that forms a family entirely its own, with no close relation to a mantis, a lacewing, or a wasp. Its early life plays out like a slow ambush. A newly hatched larva climbs onto a live spider and rides there for weeks, sipping droplets of her blood while she carries on unaware. The instant she seals her eggs inside a fresh sac, the larva slips through the silk before it hardens and works through the entire clutch, one egg after another, from within. Adult mantidflies keep the disguise going. Cornered, a wasp-patterned one pumps its abdomen sharply up and down, the exact motion of an insect readying its stinger. Though this species carries no stinger at all, only a borrowed threat. Its front legs snap shut on prey with the same spring-loaded hinge as a true mantis, yet the two lines share no recent ancestor. Two branches of the insect world built the identical trap on their own, simply because it works. A different route exists too. Some hatchlings skip the spider ride, using mouthparts built for one job, cutting straight through a sealed egg sac and reaching the same meal a different way. All three disguises trace back to one insect, and to a family unlike any of them. Camel Spider misleads on every count its name suggests. This arachnid belongs to an order entirely its own, distinct from spiders and scorpions alike, and carries no venom glands anywhere in its body. In 2004, a single photograph taken close to the lens in Iraq spread by email around the world, stretching the animal to 8 or 10 times its real size in the frame. And the myths that photograph created, of screaming, camel-gutting monsters, still circulate online decades later. By 2015, comparisons across many arachnids and their relatives had confirmed its jaws to be proportionally the largest of the group, bigger relative to body size than a horseshoe crab's or a sea spider's. Those jaws can stretch to a third of the animal's total body length, moving side to side like a pair of scissors rather than up and down, chopping prey into pulp before digestive fluid dissolves what remains for drinking. Speed adds to the reputation without earning it. A real chase tops out around 10 miles an hour in short bursts, far short of the legendary 25 miles an hour, and jumping barely factors in at all. The name for the whole group translates roughly to creatures that flee the sun, and racing toward a person's shadow is almost always about finding shade. Nothing more sinister. Peanut head bug carries a legend far more dangerous than the insect itself. Across parts of the Amazon and the Andes, folklore holds that its bite is fatal unless the victim finds a partner within 24 hours. Yet this insect has no venom to inject, and a slender, straw-like mouth built for drinking sap, barely capable of breaking human skin at all. This myth runs deeper than folklore alone. In 1705, naturalist Maria Sibylla Merian reported that the insect's swollen head glowed bright enough to read by at night, and Carl Linnaeus trusted the account enough to fold it into the scientific name itself, a name that essentially means lantern bearer. The insect produces no light whatsoever. When threatened, it turns to a second face. Its hind wings flash open to reveal a pair of huge painted eye spots, built to mimic the stare of a far larger predator. And if that bluff fails, a foul-smelling secretion follows as a last defense. The head projection that gives the insect its name can stretch to 15 millimeters on a body reaching 9 centimeters, with a wingspan of 15 centimeters, making it one of the largest plant hoppers alive. This bite myth has proven stubborn enough that clinics have reportedly given snake antivenom to frightened patients, treating a poison that was never there to begin with. Scorpionfly earns its name from a curled, upturned tail that looks ready to strike, carried high over the body the same way a real scorpion carries its own, bulbous and swollen at the tip. That tail is genitalia, used by males to grip a mate firmly during courtship, and the insect has no capacity to sting anything at all, despite the alarm its silhouette tends to cause. Genetic evidence places fleas inside the scorpionfly family tree itself, meaning the flea riding on a pet today most likely descends from a winged, scorpionfly-like ancestor that gradually traded flight and a taste for nectar for a flattened body and a life spent jumping between fur. Courtship among scorpionflies runs on gifts. A male typically offers a dead insect or a ball of his own spit to a female before mating, and the female feeds on the gift while mating takes place. One with a poor offering, or none at all, often turns instead to claw-like clamps on his abdomen, forcing the encounter when persuasion fails. Feeding brings its own daring. Scorpionflies raid spider webs for food, using a long, curved beak to lift trapped insects straight out of the silk without ever getting stuck in the strands themselves. A heist carried out on another predator's own trap, on the predator's own territory. Giraffe weevil males grow necks 2 to 3 times longer than the females of their own species, stretching in some cases to nearly half the insect's total length. And they carry it hinged and ready, swinging it like a club and locking on to rival males in duels over mates and territory. That same neck earns its keep beyond fighting. A female uses hers, together with her legs, to fold and roll a single leaf into a tight tube, seals one egg inside, then snips the finished cylinder free so it drops to the forest floor below. A piece of leaf origami built around a single offspring. The front-heavy build looks like it should limit the insect, and yet these weevils can leap distances reported at up to 100 times their own body length, launching a top-loaded frame, all neck and shoulders, that most insects would find impossible to balance, let alone jump with. One extended neck does 3 separate jobs at once, serving as weapon, courtship display, and construction tool, a stretched region of the body found in no closely related weevil. Found only in the rainforests of Madagascar, these beetles are also gathered and sold locally as jewelry and decor, fetching around $10 a piece as of 2021, a wild insect turned into small local trade. Treehopper wears a helmet unlike anything else in the insect world. By 2011, this odd head structure had earned a striking reputation as a genuine third pair of insect wings, a feature unseen in living insects for something like 250 million years. 8 years later, closer genetic evidence traced it instead to ordinary thorax tissue, borrowing the genetic toolkit normally used to build wings. Its construction backs up the confusion. The helmet attaches through flexible hinge joints and grows from 2 separate buds that fuse together as the young insect matures. Engineered with the same structural logic as a wing, even though it never becomes one. That blueprint reshapes into a sharp thorn on one species, a curled dead leaf, or a fresh bird dropping on others. On one particularly strange branch, it becomes a small, exact replica of an ant, riding on the insect's back like a hitchhiker of its own. Treehoppers also talk to each other, sending vibrations along the very plant stems they stand on. Signals completely silent to a human ear without amplifying equipment. An entire communication network hidden inside ordinary leaves and branches. The mystery began, in part, with an amateur collector who kept accidentally pulling a treehopper's helmet clean off while trying to catch one by hand. Proof enough that the structure was never fused to the body at all. 6 insects, 6 borrowed disguises, and not one of them the creature it first appears to be. The living world keeps stranger machinery running than fiction usually dares to invent.